So far we have seen the chemical molecules have symmetries, and the symmetry elements present in the molecule, and we have found out how to calculate all this, how to find out the symmetry elements present in the molecule, and also we have found out that the symmetry operations present in the molecule form a group. And I have already explained what are all the important characteristics of a group. First one, the elements in the group should obey the closure rule. Closure rule means any two elements of the group should combine to give another element which should also be a member of the group. That is called the closure rule. Second one, the group should have an identity element which is able to commute with all the elements of the group. Third one, every element should have its own inverse element in the group. And the fourth one, the function should be associative. If these four characteristics are found in a set of members, then these members are said to form a group according to group theory of mathematics. Apart from these four characteristics, if all the members of the group commute with each other, then the group is called an abelian group. If all the elements of the group are generated from one element of the group, that element is called the generator of the group, and such a group is called a cyclic group. So in order to check whether all these characteristics are found in a group, you cannot apply all these rules for each and every element and then you can separately do the finding out. Therefore, in order to make the process simple, we have constructed the multiplication table. So multiplication table is a table using which you can find out whether the members of the group are having all the four said characteristics. So first, I have explained the construction of a multiplication table for symmetry operations present in the water molecule. And secondly, I have explained the construction of multiplication table for the operations present in ammonia molecule. Ammonia molecule, the character table construction we have thoroughly did in a presentation, and I request all the students to work out, and you have to do it by yourself. Then only you will be developing the ability to imagine things, see the things or perceive things in your own mind stuff. Only when you are able to see things and perceive things in your mind stuff, then only you will be able to understand the group theory. Therefore, I always ask my students to close your eyes and to visualize the chemical molecules in your mind picture, in your mind space. You should be able to see the molecules reacting, rotating, inverting, and also reflecting. All these things have to happen in your mind step. Visualization is very important. Nowadays, the ability to visualize things or ability to imagine things has completely gone down because you are able to see things readily. That is the very big drawback of this generation. See, when I was studying group theory in St. Joseph's College, what we had was only the textbook. This PowerPoint, laptop, the projectors were not available. If at all necessary, there was a projector called overhead projector, where simply you can write something in a thin film and which can be projected. Even then, you have to visualize things in your imagination. That is why I am able to remember the group theory still now. But presently, whatever you want, you can see things in the internet or in a projector, in a PowerPoint presentation. So any faculty which is not used for more time will undergo a process called self-destruction. That is what has happened to you. You have not at all used your imagination, you are not at all used your vision, you have not at all used your mind picturing. Therefore, later on, what will happen? That particular ability will undergo self-destruction. This is the nature's first law. So, nature's first law states that anything which is not used for more time will undergo self-destruction. Therefore, I request my dear students, if at all the facilities and all the modern techniques are available, it is always better to uphold the old traditions and old methods. Try to write your own notes. Even though Xeroxing facility is there, don't do that. Printing out a facility is there, don't do that. Write with your own pen, write in a clean notebook, try to write your own sentences, try to read books, take books, printed books. Don't say that I have downloaded this book and I am reading on the mobile. No, take the book and read, try to visualize. Now, all the symmetry operations are present in the molecule. They all intersect each other in a particular point. If you look at the molecule and if you visualize all the symmetry elements, these elements will intersect at a particular point. And that point will not change its position during all the operations. So whatever operation you do, that particular point will not change its position. That is why the group of symmetry operations present in a molecule is called a point group. It is a point group. Why it is called a point group? Because there exists a point in the molecule where all the symmetry elements intersect. And that point will not change its position during all the operations. Therefore, the group containing the symmetry operations present in a molecule is called a point group. And this point group is given a name. How to name the point group? That procedure involves a very big flow chart. That flow chart has to be carefully followed. First of all, you should write the structure of the molecule and you should try to understand the various symmetry elements present in the molecule, and then you should try to understand various symmetry operations that could be performed, and then you have to write down the symmetry operations present in the molecule in a set, which is a group. After doing all these things, you have to follow the flow chart which I am going to present now, and that flow chart has to be carefully followed, and then you have to find out what is the name of the point group. It is a very scientific approach to name a point group. Now I am going to present the flow chart for finding out the point group. So this is what we have done in the previous class. So in the previous class, we have constructed the multiplication table for symmetry operations in the so this is the flow chart for identification of a point group of the molecules. So you take a molecule, carefully watch very carefully, because every line I have to explain, otherwise you will not understand. First question you have to ask is the molecule linear? What is a linear molecule? Linear molecule means any molecule which has a straight line structure, like carbon dioxide, hydrogen, chlorine. These are all linear molecules. If the answer is yes, the given molecule is linear. Then the next question is, does the molecule have inversion center I? What is inversion center? If you go from the center point in opposite directions to a particular distance, if you are able to meet the same chemical environment, then the molecule is said to have inversion center I. Say for example, hydrogen molecule, you take the center point, you move in one direction, you meet a hydrogen atom. To the same distance you move in the opposite direction, you will meet another hydrogen atom. Therefore, hydrogen molecule has I. Suppose if you take a hydrogen chloride molecule, from the center point, you move in one direction, you meet a chlorine. To the same distance you move in the other direction, you will meet a hydrogen. Therefore, it does not have I. Therefore, the first question, is the molecule linear? Yes, the molecule is linear. Then, does the molecule have I, the inversion center? If it has I, then the point group is D infinity H point group. So the name of the point group is D infinity H. If it does not have I, then the point group is C infinity V point group. So if it has I, D infinity H point group. If it doesn't have I, it is C infinity V point group. No, sir, the first question itself, I have got the answer. No, the molecule is not linear. If the molecule is not linear, then the next question you have to ask is, does the molecule have many CN axes of order greater than 2? Many CN axes of the order greater than 2. If the answer is yes, then the molecule belongs to cubic group. I will explain this at a later stage, what is a cubic group. If it is present in the cubic group, then you have to look at the molecular formula. If it is of AB4 type, it is called TD point group. TD means tetrahedral point group. If it is AB6 type, which means octahedral point group. If it is A12, B12, ipsahedral point group, IH, ipsahedral. Therefore, if you say no, that is the molecule is not having many CN axes with order N greater than 2. So if it is not containing, then you have to ask one question, does the molecule have NC2 axis perpendicular to CN axis? See, look at the difference between this question and this question. Here also one CN comes, here also one CN comes. See, the difference in question is, here you are worried about many CN axes. The CN means can be C3, C4, C5, C6, anything greater than 2. And that too, it contains many. Say for example, it contains, say, AB4 tetrahedral methane is containing 4 C3 axes. How many C3 axes? 4. C3, therefore N is greater than 2. How many? Many CN axes, 4. Therefore, it comes to the tetrahedral point group. But here what we mean, it contains only one axis with order greater than 2, but it has C2 axis and the number of C2 axes present is equal to N. Say for example, I take boron trifluoride molecule. So BF3 molecule. Suppose if you have a notebook with you, you write down the structure of trigonal planar BF3 molecule. That trigonal planar BF3 molecule is containing one C3 axis at the which passes through boron, which is perpendicular to the plane of the notebook. So it contains a C3 axis, and you can assume 3 C2 axes passing through BF bonds. Therefore, it contains one C3 axis, and this N3 is coming over here. Therefore, it contains 3 C2 axes, which are perpendicular to C3 axis. So, in such a condition, if it is yes, then the group is called dihedral group. Dihedral group. And apart from this condition, if the molecule has sigma H, then the name of the point group is DNH. If it has n number of sigma D, then the molecule point group is called DND. If no planes are there, it is called DN group. Say for example, up to this point, I want to take molecule boron trifluoride as an example. You ask from the first question, is the molecule linear? No. So move to the next question. Does the molecule have many CN axes of order greater than 2? No, because it has only one C3 axis with the N greater than 2. Therefore, you are coming here. So here you are asking the question, does the molecule have N number of C2 axes perpendicular to the CN axis? Yes, it has a C3 axis and 3 C2 axes perpendicular to the C3 axis. Therefore, you are moving over here. So BF3 molecule belongs to dihedral point group. So in the dihedral point group, you know that BF3 molecule contains 3 sigma V's, that is vertical plane. I have already explained what is a vertical plane. It is a plane of symmetry. If the plane of symmetry contains the principal axis, it is called a vertical plane. If the plane of symmetry is perpendicular to the principal axis, then it is called horizontal plane sigma H. And I have also explained to you what is a principal axis. The axis which has the greater number of order, whose order is the highest, that is called the principal axis. Therefore, in boron trifluoride molecule, C3 is the principal axis. Now, the question is whether it has sigma H. Yes, it has the sigma H. The horizontal plane. Where is the horizontal plane? It is the molecular plane. The plane in which the molecule is cut into thin sheet-like structures. That is the plane. So that plane is perpendicular to the C3 axis which is present. Therefore, according to the condition, sigma H is present. Therefore, it belongs to D3H point group. D3H point group. So this is how the point group is found out. Suppose even here also you get the answer no. If you get the answer no means what? The molecule is not having Cn axis n greater than 2. That means it is having only C2 axis. Then if it is no, you are moving over here. Does the molecule have the Cn axis? Yes, it contains the Cn axis only, not a perpendicular C2 axis. So if it contains a Cn axis only, come here. Along with that, if it has a horizontal plane, it is CNH point group. If it has n number of sigma V, CNV point group. If it has no planes, CN point group. Now you take ammonia. Take ammonia molecule. If you have a notebook, write the structure of the ammonia. Step by step, I will explain. You do the exercise. Write the structure of the ammonia. Ammonia is pyramidal in shape. Therefore, it contains E, C3, sigma V dash, sigma V double dash, and sigma V triple dash. Now look, start from the first question. Is the molecule linear? No. Does the molecule have many Cn axes of order greater than 2? No, because ammonia molecule contains only one C3 axis, therefore no. Does the molecule have n number of C2 axis perpendicular to Cn axis? No, because it contains only one C3 axis and it has no C2 axis at all. Does the molecule have Cn axis? Yes, it has a C3 axis. Okay. So next question. Does it have sigma H? No. Does it have n number of sigma V? Yes. How? It has a 3 sigma V. What is the axis? C3 axis. So C3 axis containing 3 sigma V's. Therefore, the molecule exists here. Therefore, the point group of ammonia molecule is C3V point group. Similarly for water. Take water. Is water. Have you taken down? Are you trying on your notebook? 18 chemistry 28. Please unmute yourself and respond.
Yes, sir.
Are you writing on your notebook?
Yes, sir. Yes, sir.
Are you able to follow the flow chart?
Yes, sir.
Okay, right. Okay. You take water, water molecule. Is the molecule linear? No, because it is bent shaped. It's bent shaped. Does the molecule have many Cn axes of order greater than 2? No, because it has only C2 axis. Does the molecule have n number of C2 axes perpendicular to Cn axis? No, the molecule does not have Cn axis at all. So does the molecule have Cn axis? Yes, it contains a C2 axis. How many reflection planes are there? 2 reflection planes are there. What are they? Sigma V and sigma V dash. Therefore, it also comes here. Therefore, the point group of water molecule is named C2V point group. If no planes are there, then the molecule belongs to the point group Cn point group, Cn. Even here, if you are getting the answer no, then you have to ask another question. Does the molecule have the reflection plane alone? Does the molecule have the reflection plane alone? Only reflection plane is available. Such a molecule you can have reflection plane. I will tell you the molecule at a later stage, which contains the reflection plane alone. Then that belongs to the point group CS point group. If the picture is not clear in the presentation, you can note down in your paper, it is CS, C suffix S point group. So in another 10 minutes, the meeting will be cut off. I request all of you to re-enter through the same password and link. So if it is no, then another question is, does the molecule have only the center of symmetry? Center of symmetry means I only present, nothing else is present. Then you may ask the question, sir, here also the same question, whether it contains the center of symmetry. Here also the same question, whether it contains the center of symmetry. So questions are different. Here it contains only center of symmetry, but here it contains C infinity axis and also center of symmetry. And also here the molecule is linear. Here the molecule is linear. Here the molecule is not linear. So does the molecule have only center of symmetry? It belongs to Ci point group, Ci. If the center of symmetry also not present, then it has only Sn axis, improper axis only, and also that improper axis having the order greater than 2. If it is so, then that belongs to Sn point group, S suffix n. Even that is not at all present, then the molecule has only identity element. It is not belonging to any symmetry, then it is called C1 point group. Therefore, this flow chart is available in the 24th page of group theory book by Dr. K.V. Raman. If you want this flow chart, I will take a snap and post in the Google Classroom. You write down the flow chart and try to find out the point groups of various molecules given. Now I will be, after this only 8 minutes or more, and after that I will take some of the molecules and then I will explain how to find out the point group of the molecule. So in 7 minutes, you first take down this flow chart. I give you some time, take down this flow chart, and then you try to find out the answers for the molecules which I'm going to show you now.